Welcome to the Real Python Podcast. This is episode 27. What is an effective way to prepare for a Python interview? Would you like a set of problems that increase in difficulty to practice and hone your Python skills? This week on the show, we have Jim Anderson to talk about his new Real Python article, Python Practice Problems. Get ready for your next interview. The article provides several problems that include skeleton code, unit tests, and solutions for you to compare your work. David Amos also joins us this week, and he's brought another batch of PyCoders Weekly articles and projects from the Python community. We covered these topics: structural pattern matching, common Python data structures, a tax attorney uses Python, discover the role of Python in space exploration, and 5 pairs of magic methods in Python that you should know. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, David.
Hey, how's it going?
So we have a guest this week.
We do.
Jim Anderson has joined us. Yeah.
Hey, guys.
So welcome to the show, Jim.
Thanks.
Yeah, welcome.
Thank you.
So we wanted to have you on partly as a Real Python team member, but also to talk about an article and kind of a new format for Real Python you just kind of created here. So do you want to talk a little bit about it?
Sure. Yeah. We're really excited. We've got a new format that we've come up with. The article is called Python Practice Problems, and it's really about allowing readers to get some practice before interviews. And so it's a series of progressively harder problems. And format is we give you the problem statement and then have a collapse section where we give our answer that we as a team came up with. And you can kind of stop reading at some point and then go off and work through your solution and see what you come up with and then come back and compare it against what we did.
And it has like a testing mechanism of sort?
Right. We provide a repo with skeleton code and unit tests there, so they can download that and get a starting point of, okay, here are the tests that you need to pass to get this problem solved.
What are the types of problems that you're doing inside of it?
They're generally all command line stuff. And so there's, some simple ones like count, give me the sum of all the first n integers is where we start. And then we do some simple cryptography and processing some log files. And then at the last one is a little bigger than the others. We write a Sudoku solver.
I could use that. I found a new Sudoku game that I really like by these iOS developers. They do some kind of cool stuff. So it's called Good Sudoku. And it's pretty fun. Sometimes these super hard ones, it's like, I'd like to learn some more techniques.
Yeah, there's just, if you search on it, there's just a ton of different techniques of how you can do that. And I actually started trying to code those up and realized that may not be the most efficient use of my time or the computer's time.
Sure. Yeah. So right now, the article is available for anybody who's a subscriber to Real Python, where you get the video courses and all that sort of stuff. And then it's going to go live this coming Monday, I believe, right?
Correct, the 21st.
Because we're recording this. Yeah, okay, we're recording this in advance. So is that a common thing that we're going to try to do more of?
I think so. I mean, this is the very first time we've released an article in this format with like the test cases that you can run and really encouraging folks to write out their own solution and then test it out to see if it works before they look at the solution that we provide. I think it's going to be popular. I mean, there's been a lot of demand for something like this. And yeah, I think that, unless something crazy happens, I think we can expect to see more articles like this. I think it'll be a popular format. One of the things that I really like about it is that it gives you, I like the testing part, because it kind of gives you like, here's the, the specifications that it has to meet in order to be a solution to this problem. And then you can use that to then write your solution. And in some cases, especially for probably the log file processor and the Sudoku solver. I mean, there's so many different ways to solve those kinds of problems.
Yeah.
So there's a good chance that the solution that the reader comes up with may not be exactly the solution that we provide. So you get to then compare notes and kind of see the differences and different approaches to those problems. And that's always a good way to sharpen your problem solving skills, is to consider those different kinds of solutions.
Yeah. Have you, Jim, in learning programming or looking for work, have you run into these kind of interview question things? Have you been presented that for a job?
Oh yeah, absolutely. Some of them, I've had them vary all over the map. I don't think I've ever gotten one live that was as complex or involved as the Sudoku solver. I think that one's probably
Sure.
a little more than I've seen. But the other ones, I've used some form or another doing interviews myself when I'm interviewing candidates to hire.
Okay.
So yeah, these are definitely things that are pretty close to real world problems.
Yeah, when I got the last job I was working at in Hawaii, I was, again, starting in Python. I had that experience of two things where I had like a take home, it was more of a data processing job. So it was like, here's some data, and they had me kind of create a solution inside of a Jupyter notebook. But the other one was like a coding, and it was kind of a neat experience. Trying to come up with, a solution kind of quickly. And again, the main idea was just like, do you understand the fundamentals, and are you what's your thought process going through this, and sort of documenting as you go, which was really kind of cool.
Yep. Yeah, the screening process I've had at some of the larger corporations I've worked at, they didn't always get, the candidates would vary all over the board. And so the real simple one that just add the first n integers was a useful screen, just to make sure the person that the HR department sent us was actually knew how to code a little.
Yeah. David, have you had that experience at all?
Actually, no, I've not had like a traditional interview for the jobs. They've been more sort of like start with a project and let's kind of see how you do, and then kind of grow from there. So that's been
the problem solving kind of thing.
Yeah, and in my first programming job, I got really, it was sort of the stars aligned, I guess, for both both parties involved. I was fresh out of graduate school and in need of a job, and the company that I went to work for was an audiovisual company that did these large installations of with lots of automation. So they were doing things like universities and hospitals and schools and things like that. So with big distributed systems, and they needed a programmer to program the control and automation for it. And so it was just kind of like, just come do it. And if you're successful on the first job, then you've got a job here. And so everyone was, I guess, just desperate on both ends. And then it worked out. And then I found
very sink or swim.
Yeah. And then I found myself, and as a professional programmer coming from a math PhD into professional programming. So,
yeah,
there you go.
So David, what's your first topic you got there?
First one I've got is from Jake Edge over at lwn.net, who does a lot of Python news reporting. And this one is called Structural Pattern Matching for Python Part 2. So this has to do with the PEP 622, which is on structural pattern matching, that came out, I guess, back in June, maybe around there. And he reported on this back then. And so now it's catching up on the discussion and the involvement, the evolution of the PEP. For those that aren't familiar, PEP 622 proposes a match statement for Python, which is similar, I guess, superficially to things like the switch statement from C. It's a little bit different, though. So you have like a match on some variable or some expression, and then different cases, and those cases compare that variable, that expression, to different cases, so like the simple example would be like match X, case 1, then you would maybe print 1, case 2, you would print the number 2. So the 1 and 2 it's comparing X to the values 1 and 2. But you can get more involved. You can compare things like maybe you have a tuple, X and Y, or X comma Y in a tuple, and you want to match any case where the first component of the tuple is a 0. Well, you could do that using these pattern matching expressions. So it provides a lot more power than just kind of your standard C switch statement. It's been, I think, pretty popular in the community. A lot of people see the value in having something like this, but it has not been without its pushback. And one of the things that's been interesting with the discussion over this is that became sort of like this meta discussion over how debates should actually happen and how those debates get documented. So there was actually a proposal that maybe we need something like an anti-PEP, a formal document that is in opposition to a PEP. This was proposed by Mark Shannon. And actually, Raymond Hettinger, if you know who he is, was a proponent of this. He thought, yeah, we need some kind of formal document. Some of the others said no. Like, I think Brett Cannon was on the side that said, no, I think, we've got a rejected ideas section on existing PEPs. We can use that to document those kinds of things. Maybe we add a new objections section to the PEP to document that stuff. Basically, Brett Cannon said something, that's what the rejected idea section is supposed to capture. If a PEP is not keeping a record of what is discussed, including opposing views, which the PEP is choosing not to accept, then that's a deficiency in the PEP and should be fixed. And if people feel their opposing view was not recorded properly, then that should be brought up. So it's interesting. It's brought up kind of this discussion of, how do we capture and record the debate, and how does opposition have a voice in this? But then there's also been some updates. So I'll go over a couple of things that have changed since the last version of the PEP. And one of those, the big one, is that they've removed this dunder match protocol that would customize how a class gets matched. And that was just removed so that they could give time to see how these match statements are actually being used before they then sort of implement this protocol. So it's not, I guess, removed permanently. It's just sort of put back on the shelf to we're just going to wait and see how people are actually using this, and then we'll come up with some sort of protocol on customizing your classes for how they get matched. The other big change was originally, if you wanted to use a constant in a matching expression. So let's say you had a constant called use_rect, which was assigned the string value rect for rectangular. So this would be maybe between polar or rectangular coordinates for something. And you wanted to match a tuple that had, say, the first component was this rect string, and then anything for the other two components in a tuple. Well, if you tried to use in your matching expression this use rect constant, or quote unquote constant, Python isn't able to distinguish that this is already a constant versus a variable that it would be allowing some degree of freedom there in the matching expression. Hopefully that makes sense. So the original thought was, okay, we'll put a dot in front of that variable name, and that'll say, hey, there's a variable in my namespace already there's been assigned some value. Replace this with the value of that variable, and that's what we should be matching on there. So use this leading dot. Well, people didn't like that. And they thought it was ugly. And now we have to have other, all this new syntax for everything. So what they decided to do was sort of a medium, was that if you had an existing namespace that you could refer to, and then use the dotted notation there. So maybe you had an enum of colors, right? Color.red was equal to the string red. Color.blue was equal to the string blue. Well, then you could use color.red, and that it would pick up on and say, okay, I need to replace that in the matching expression with the literal value that is assigned to that variable. So that's been, I guess, kind of a little bit of tug of war that's gone on there with how they should handle that. But anyways, at this point, it seems like the PEP is just waiting on the steering council to accept or reject. I think it sounds like there's enough momentum, and Guido he's one of the authors on this, and he's a big proponent for adding this feature. So, I think there's a good chance that in Python 3.10, we might see the match statement come to fruition. Yeah.
That's very cool.
So my first topic is an article on Real Python, and it's actually from Dan Bader. And it's a take on his book. Actually, it's kind of an abstract from one of the chapters of the Python Tricks book, which is how I got kind of introduced to Dan in the first place. And it's really, really in-depth, talking about the common data structures in Python. It's a real great read. And as very often you'll see on Real Python, when they have the parentheses around the word guide, it's definitely a deep dive for you into it. And so this is going to talk about diving into dictionaries and maps and hash tables, talking about array data structures, records, structs, data transfer objects, goes into sets and multisets, eventually gets into stacks and the different types of data structures you'd want to use for that. If you want to do like a LIFO, last in, first out type, or a queue where it's first in, first out, FIFO. And then at the very end, it kind of gets into this little area of priority queues. And in each case, there's all these practical uses with code and potential ways that it could be used in various types of algorithms you might be thinking about. So it's this real large article diving into all those topics. If you haven't really had a chance to get exposed to Dan's Python tricks book, it's a really great way to kind of get introduced to that and kind of see the value of like, okay, some real world applications. I always thought of his book as the step that I needed to go from when I was just a beginner and just learning some of the fundamentals of Python, and then like, okay, let's learn some of the more important things about how to apply it in that sort of intermediate stage. And it was very useful. And I feel like this article follows along in that. And it's like, okay, well, why should I know all these different forms of common data structures, and how could I use them? And it's a really useful tool for everybody to check out.
Yeah, it's a really good overview of everything that's available. And all this stuff is in the standard library.
Right.
And this is really that, batteries included mentality of Python. I was actually kind of shocked when I came to Python, learned the basics and everything, and then realized that like, wow, all this stuff is like already implemented for me by really smart people too that know what they're doing. So it's just, it's neat that this is just all at your fingertips. And there's all sorts, he goes into some of the stuff that I thought was actually kind of surprising and neat that he actually went into it. So for example, in the dictionaries, maps, and hash tables, he's got a section on the mapping proxy type in the types module for making like these read-only dictionaries. So he goes really deep into like what's available. It's really cool. Yeah.
Yeah, I like that about it. It's not just like, this is a dictionary, fundamental stuff. It goes into a lot of the why and all these kind of alternative cases from the collections module. It's definitely a deeper dive into that, which I thought was really nice. So
yeah. And then I guess if you read this and you're interested in these priority queues, which are useful, really useful structures.
Yeah.
We also have an article specifically on the heap queue module that takes an even deeper dive. Dan kind of just touches the surface on like, here's this heap queue thing and kind of a quick example. And then we've got a deeper dive as well on the heap queue module itself.
And then we have the stacks one, the article that you did, right, Jim?
Yeah, that's right.
Yeah.
Cool. I'll link all that stuff in the notes here. I want to shine a spotlight on another Real Python video course. It covers the topic we touch on during this week's episode. It's titled, How to Implement a Python Stack. The course is based on a Real Python article by our guest this week, Jim Anderson. In the course, instructor Liam Pulsifer takes you through how to recognize when a stack is a good choice for a data structure, how to decide which implementation is best for your program, and what extra considerations to make about stacks in a threading or multi-processing environment. I think it's a worthy investment of your time to learn how to implement this type of data structure in Python. And like most of the video courses on Real Python, the course is broken into easily consumable sections, and you get code examples for the techniques shown. Check out the video course. You can find a link in the show notes, or you can find it using the newly enhanced search tool on realpython.com. So what do you got next, Jim?
I've got something from Andrew Mitchell. It's called A Tax Attorney Uses Python. And I really like this article. It doesn't have any code in it. It's just words, but it is describing how he's using Python to kind of automate his day-to-day stuff and solve specific tedious problems he's got to do in his job as a tax attorney. And the reason I really like this is just he kind of goes through and lists, here's the things that I have to do, and here is how I can use this to really save my time and provide a better service to my customers. And for me, it really speaks back to, I know you spoke to Michael Kennedy recently. He keeps talking about, programming as a superpower, that even if programming isn't your job, it can help you do your job so much better. And I think this is just a great example of, he's got things like he goes through his website and he's got 1,200 PDF files, and he goes and searches for a whole bunch of different errors that could potentially happen where the title's out of whack, or there's two places that are pointing to the same article, and making sure those are in sync, and scraping IRS websites, things like that.
Yeah, definitely.
Yeah, that's got to be a big time saver. I hate to do that manually. So yeah, I like where he's coming from, and the message he's presenting here is really just, you don't need to be a software developer in quotes. You can just use this to make your job, your life easier in all these different ways if you just look around.
Yeah, I worked in a law office just before my last job, and it is very interesting. Like my job was basically learn all of their software, all their tools, and then teach them to them, which was a very interesting kind of job. And, I didn't have much background in law. My father-in-law is a lawyer, but I never really talked to him much about it. But it was very interesting to learn their processes and just the amount of, documents. And, it's just such a huge thing. And we've spent, I don't know how many episodes now where we've talked about PDFs, and definitely there's a lot of resources there, because it's just like such a common thing that small businesses, and I can imagine, him being a tax attorney, just like the overload of like, how many files and cataloging that stuff. And, the law firm, we had a whole library system where you would, check in, and this whole system where they had to like, check out specific documents to make sure that nobody's making a change to the existing document, kind of like Git, for code, but this is for all their documents, because there has to be this paper trail, which is very, very interesting. So.
Yeah, this is one of my favorite things about Python. Python's not really the only language, I guess, that you could use for this kind of stuff, but, a tax attorney's not going to learn C++ to like automate things in their life, right? I mean, they're going to spend too much time just learning how to get their environment set up, and then they're going to give up and be like, this is, forget about this, right? Whereas Python, it's like they can just get started so quickly. And, I mean, there's a few other languages you could use, but the ecosystem that exists in Python, everything, it makes it really well suited for these types of applications. And I think it's just awesome that, there's people out there in the real world that are, spend a little bit of time to learn some Python, and then save, ultimately end up saving way more hours than I spent learning the language on, the time that it saved me just from doing these mundane things.
Yeah.
One of my favorite things that he talks about is the last item in his list here, summarizing information for study and review. And he says, periodically, I like to review the items in my database. I have a Python script that extracts selected items from the database and exports them as a text file to Dropbox. From my iPad, I import the text file into a text-to-speech program, and then he can simultaneously read and listen to that text out loud while he's preparing for something. And I just think, like, man, that is like such a cool time saver, right? Like,
oh yeah,
you have a little script, pull it all out into text, and then have the computer read it out to you. Like, there you go. That's really, really great.
One of the things I really like about the article is that there isn't code. It isn't about the code.
Yeah.
And a lot of times when people are learning coding, they get really hung up on, I need to make this Pythonic. Does it look right? Is it, and this kind of brings up it doesn't matter what the code looks like. It doesn't matter if it's the ugliest code in the world. That's saving him time.
Yes. Yeah.
Right? It does, here's the task, and it does the task. And that's the cool thing.
Yeah.
So David, what you got next?
Next up, I have a super cool collaboration between Microsoft and NASA. And I think by now people know that I'm, kind of a space nerd. I used to I wanted to be an astronaut when I grew up, and I still do. And I'm waiting to grow up so that I can become an astronaut. It's a learning path that Microsoft has put together. It's called Discover the Role of Python in Space Exploration. And I went through a little bit of it. They estimate about 3 hours to go through it. So I didn't have 3 hours to sit down and go through this whole thing yet, but maybe this weekend I can look at it. But I went through the first few modules, and it just describes like, why are they doing this? Why are they interested in talking about the role of Python in space exploration? It talks about this Artemis program that they're working on now, which the ultimate, maybe not the ultimate goal, but one of the short-term goals is to put the first woman and the next man on the moon by 2024. They talk about just the role that machine learning and artificial intelligence and programming plays in space exploration. So it's designed really for new coders, although you could probably either quickly work through that module, or I don't know if you can skip it, but if you already know about coding. But there's a module that introduces you to Python and some of the basics of programming, and then setting up an environment in VS Code. And then the next module actually goes through some problems, like works on solving problems related to space exploration, and in particular the Artemis program. Just kind of introduces you to how Python is used in that space. So it's really it's just really cool. I mean, this would be the ultimate way if I didn't already know Python. Like this would I would be like, oh yeah, absolutely, I'm going to sit down and learn Python so I can I can learn about this. And it's just a really neat collaboration.
Yeah, it's nice that they're releasing so much of this stuff. It gives all these sort of real world, I don't know, we were just talking, Jim, before we started recording about, when I went to school in engineering in the 80s, and showing my age. And, and I ended up dropping out because I was not super interested in it, because I didn't see as many of the real world kinds of things to do with it. And if you're getting into programming now, there's so many resources, there's so many super interesting projects, and the data is open and being shared, and all these kind of projects to get people into this sort of stuff. So if in my case, if I'm interested in music and video and all these kinds of things like that, in your case, if you had this stuff, if you were as a kid, you would have been all over it,
Definitely.
Yeah, that is really cool.
Yeah. Last week, I asked a favor, that if you like the show, could you leave a review on Apple Podcasts? Well, I want to thank a couple of people who left reviews. Eva Nave wrote, every episode of the podcast has so much information packed into it that you want to listen to each episode 2 or 3 times, and then spend hours down the rabbit hole of each link to the resources discussed in the episode. You will be a better Python programmer after listening to this podcast. Thanks, Evo. Mark Johnson wrote, as a former accountant leaning into Python and passionate about process automation, this has been a great resource. It's a great jumping off point to keep going deeper. Thanks, Mark. These reviews really help the show. Reviews and ratings are a great way for more people to learn about the show. And as the show grows, it's helping to attract more guests. And I want to make sure to share even more of their stories and knowledge with you. Thanks again. My next one is an article that's on Medium. And we talked about Medium before. Just, be careful. It is one of those ones with a star. So you'll have to watch how many reads you can do on it. But it's called 5 Pairs of Magic Methods in Python That You Should Know. It's under the heading of Better Programming, I guess is the blog name. And it's by Yang Kui. And it's one of these things that I had a hard time initially. Again, when I started learning Python, everybody referred to these as magic methods. I think they're more commonly referred to as dunder methods because they have the double underscore in front of them. And, if you're doing object-oriented Python, you will have run into these. Yep. And some of the first ones that I ran into when I was trying to learn it, obviously, would be, instantiation. And so it goes through these 5 pairs. And the first pair is the instantiation pair of new and dunder init, which you may have seen already in a lot of Python code. And so this is what happens when you create this new object, what code has to be run to initialize it. I think that one's pretty fundamental that, again, if you've done any object-oriented, you need to understand those two. The one that I got caught up on when I was doing one of my first tutorials, I was learning to do decorators on Ger Arna's article, and he was using the repr, REPR, so dunder repr, and I had to kind of shake my head. Okay, well, what does that mean? And I'm like, okay, I think it means representation, and kind of based on it. And then the pair with it is the string one, and so those two are pretty vital to understand, in the sense that if you're going to create these objects, and then you want to be able to sort of log and follow what's happening as these things are created. If you were to call the, actually, just like you're inside of a REPL and you type the name of the object, when you do that, the repr would actually show you the actual, like, okay, what is this object and what is involved in creating it? And I mean, that's the main idea. Very often people just use the string one for it too, like, and what is this object? But the representation one is like, okay, what are the steps that are involved in creating this? Like it's, say the class is a car, and then, the color and so forth. And so this would show all the different components kind of creating it.
Mm-hmm.
And the next few are very interesting as you dive deeper in talking about iteration. So it would be dunder iter. So how does this thing, if it's going to be an iterator, how is it going to walk through those things? And so what's the method involved in iterating? And then along with that, what happens when you call dunder next as it kind of goes through this? If you have a particular object that's going to be an iterable, that has a group of things or a list of things or what have you, how's that going to function inside there? And then it goes into context management with enter and exit.
Mm-hmm.
So if you use the context manager, the typical way of writing that is like the with, like you might have used it for with open for, creating a file, or in that sort of context of like cleaning up after you've opened and then, sort of it closing it for you. So a context manager has these two methods that what happens when you enter into that context, when you go into the with, and whatever's under enter will automatically be run. And then whatever code happens in between there. And then again, there's sort of a cleanup phase with the dunder exit. And so I think that's super useful to understand, like, if you're going to have something where you want to use this in a context and be able to have it kind of controlled, it's very useful. And the last one is about attribute access, which we've talked a little bit about because we were talking about decorators, but the get attribute and set attribute, which are get attr attr and set attr attr. So yeah, I think it's a good rundown of all those kinds of things, and I agree that these are the ones that you really should know if you're going to dive into object-oriented in Python and get kind of an idea of what these things can do for you. And they're not necessarily magical per se, but they are extremely useful tools to make sure you got under your belt before you dive too deep into object-oriented in Python.
Yeah, I remember learning about enter and exit. And until then, I'd kind of seen some of the dunder methods and thought, oh, that's kind of interesting. But learning about those, and it's like, oh, I can make my own context manager. Yeah. It's not just something under the hood that the language is doing for me. I've got hooks to create that, and just the opening up of possibilities that you can do with that. And there's some really interesting code you can write and simplify by making something a context manager. It's that really opened my eyes when I saw that.
Do you have an example of something you created?
Not off the top of my head, no.
That's okay. I was trying to think of some other ones. Obviously the file one is such a common one, but I was trying to think of some other things that you did. Go ahead, David.
I've used it in the past to create like custom file handlers.
Okay.
Like for specific kinds of files, so that I can do like, with, and then like my own version of like the open that'll do a little bit of extra stuff, like verifying that it actually has, that it actually is the type of file that I think it is. Like it has some, specific bit, at the header and things like that. So, yeah, just little things like that. So that's where I've used it.
Cool.
But it's not something I do often.
Right.
One comment I wanted to make is he's got the very first pair that he talks about is dunder new and dunder init.
Right.
And he doesn't really give an example of where dunder new is used. And I think it's one of those things that I programmed in Python for a long time before I ever even, I think probably I saw dunder new at some point, but was never.
It's very rare. I was trying to think of ways I've seen it.
So I think a common way that it's used is to create like a singleton class, where every time you instantiate the class, you get the same thing back. And that's, I think that's probably one of the most common uses for it. And I just wanted to mention that because he doesn't really give an example. Some of the other ones, I think he gives some examples, but here he doesn't really give an example of like why you would want to use dunder new. However, in the case of the singleton, there is some debate over whether or not that's actually a good fit for something like Python. And so Brandon Rhodes has this python-patterns.guide website, which is a fantastic website to learn about design patterns and everything like this. And The singleton pattern, he goes through a whole example of how you use dundernew to create a singleton class, so that every time you instantiate it, you get the exact same object back in memory. And he recommends the alternative of the global object pattern. And that is where you have like a module or a namespace somewhere that has that instance of an object in it. And every time you need to use that object, then you get it from that. So this would be like if you create a class maybe in a module and then instantiate the class with what you need. And then every time you need that object, you just grab the object from that module. That way you're always getting the same thing. So it's this like global object pattern. That is actually the way a lot of things are done in the standard library rather than using dundernew to create singletons. So anyways, just some commentary on that, because it's one of those ones where it's like dundernew, like that's cool. Okay, it gets called before dunder init. I can put some stuff in it to do some other stuff, but why would I ever actually use this, right? So there you go. That's why you might use it.
Yeah, your example, I'll include a link to the article you're mentioning, because I think that makes a lot of sense. I've rarely seen the dundernew used, but the idea of it being kind of modular in sort of the global space makes a lot more sense to me too. Like I can kind of see what you're talking about.
Right. Yeah. And, I don't know, I haven't had a lot of need in my own programming for things like singletons or anything. So, I don't really have a particular stance on this whole debate of like, should you use singleton pattern? Should you use global object pattern? Like, I don't know. I guess it really just depends. But Brandon Rhodes does make this one comment. The one situation that would really demand that you use the singleton pattern is if you have an existing class and that because of some new requirement now needs to operate as a single instance, then having dundernew allows you to go in and just modify that to then become, to follow the singleton without having to like restructure a whole bunch of stuff. So it's a good, if your requirements change, you can go back and do this. So that's his opinion that like, that's where it really, demands it. Otherwise, he suggests using this global object pattern.
Cool.
So his 2 cents.
Yeah. I wanted to dive into our next part, which is projects. And so it's kind of nice as we get 3 picks this time for projects. And Jim, you have one that I was super interested in also.
Yeah, I stole it from you. Yeah, this is a throwback one. Again, Brandon Rhodes. He's our theme for today, apparently.
Oh, yeah. Yeah.
He's had a project for a while, but he's just updated it a bit. He has ported the old 1977 Fortran program called Adventure, which is a command line program where you do a kind of go through a dungeon, go through the Colossal caves and pick up treasure and gold and battle things. And I remember doing this in college when I had access to old mainframe systems. But he says it's a faithful port of Adventure to Python 3 from the original 1977 Fortran code.
Nice.
And one of the cool things I thought was really neat is that not only can you just run it as a standalone program and it runs, but you can also load it up in the REPL and play it in the REPL. And it's almost the same thing both ways. The REPL, there's some syntax issues where you have to do parentheses on some of the 2-word commands and whatnot. As far as, games go, and it's not any of the new high graphics things. It's all just, you are in a building, a well house for a large spring, that sort of thing. But it's sort of fun to go back and see this again. It's been a long time.
Yeah, text adventures are, I don't know. I played with them quite a bit, and we were talking again offline about this before, how I remember going over to a friend's house and finding a copy of Byte magazine and typing in the code into his Apple II, just kind of learning BASIC at the time, and kind of that manual process of testing and finding your errors of everything you've typed in and copying it in. But that was some of my first experiences of coding.
Yeah, same. That was I when I was a little kid, I learned BASIC on my parents' IBM. I think it was like a 386 or 486. I can't remember exactly. But the very first program that I ever wrote myself was a little text adventure game. So, yeah.
Nice.
Yeah. My first one that I completed was like a D&D character generator kind of thing.
Oh.
And then I created a kind of like a surround game, like you had to have 2 players for it, but sort of a copy of that. Again, really simple blocks on I had this I don't know if I said this before on the show, but my parents knew I wanted to get into computing. And I'd say to I had a paper out and I'd say all my money and I bought a ColecoVision.
Oh,
I don't know if you guys remember that system.
Yeah.
So there was this attachment that made the ColecoVision still attached to your television. It made it a full-fledged computer as an Apple II clone. It was called the Atom. And so I had that. And that's where I was learning it. And you could do, logo, and you could do other kind of basic graphic kind of stuff with it. And so I made like these, very block pixel kind of surround game with it. But that was like, it was kind of crazy. It had tape drives, which I hated. You had to
you had the old cassette drive.
Yeah,
cool.
But it was not rewind it yourself and hit play to bring it in. It was sort of controlled. And so it would go and search for the data or, kind of try to find its space. And it was very bad. I talk about linear access versus random access. It was very painful. I wish I had a drive, hard drive or what have you, but that was later.
I didn't realize how lucky I was to have the Apple II with the 5.25-inch floppies.
Oh yeah, I would have yeah. And it came with a horrible daisy wheel printer with the impact, kind of thing. It was the noisiest thing, but anyway, at least I could do basic papers for, at the end of high school and so forth. Cool. So, what project do you have, David?
Mine is called Clifford.
Okay.
And it is not about the big red dog.
Bummer.
It is about, it is way nerdier than that. It's Clifford Algebra, or what is called geometric algebra, doing these kinds of things with Python. So that is a pretty esoteric topic, I'll admit. It really speaks to me as like the recovering mathematician that I am. And what I think is cool. So it has big applications in things like computer vision, robotics, computer graphics. So Clifford algebras are all about transformations of space. So doing things like rotations and other kinds of transformations. So you can see where that would have big applications in graphics and things like that. So as well as robotics. So this is a really pro module that they've a package that they've put together, and they've got some really good documentation on how to get started with it. It is definitely geared towards the academic.
Okay.
I would probably say to a lot of software engineers out there, they probably this doesn't look very Pythonic, but to a scientist or a mathematician or someone coming from academia, the notation would look very familiar to them, how they would write things by hand and be talking about things. And it's definitely it's powerful. It's got all these different operations already implemented for working with these things called algebras and everything to do all these calculations. And it also can do some space-time physics. So going back to the whole space and everything. But yeah, so they've got examples of how you do some theoretical physics with it, and Lorentz transformations and things like that. So I just thought it was really, really cool. Just appealed to my nerdy side.
Yeah. I mean, you talked about robotics before, and I think about, the idea of mapping out even something as simple as a Roomba, vacuum mapping out your, geometry of your house and so forth. And just thinking about all those kind of the dog one we did, was that last time?
Yeah.
Yeah. And so thinking about, planning where those things would be, and there's a lot of geometry there. So I can imagine that a library like that would be useful.
Exactly. And it's all about efficiently representing these rotations and transformations. And that's where this really, comes in, because you need some efficient representation there to be able to handle some of that stuff. So
cool.
Groovy.
Very cool.
Yeah. So my next one is called, I'm guessing it's pronounced pippi, Pippi, and it's computer music with Python. And it's a neat little library. It's sort of a DSP sound library. It's mostly not real time. The idea is that you can sort of program out what you would like to create with these sounds. It has a lot of examples inside of it of sounds like, hi-hats or drums, or they have some sound samples in there of guitar, but it allows you to mathematically sort of plot out okay, I'd like, these sounds to be combined together. Gives you different ways DSP wise to add them together, to change their pitch, to modify those kinds of things. And then basically you're outputting waves or FLAC FLAC files. And I had fun kind of diving into it and going through the tutorial and learning some of these really kind of cool DSP things that are happening. A lot of it's happening in C underneath the hood. But if you're interested in sound, like me, and like to get into those kinds of things and want to learn a little more about like, okay, all right, how can you do FM synthesis? How can you do creating a wavetable oscillator? These different ones of like plucks and anyway, and then it has lots of again the types of effects that you would have like vibratos or filters, and so it's a lot of fun. Again, just to kind of dive in and then use Python to kind of combine those things together. I could see myself creating, unique new sounds and also kind of creating little like kind of loops and things that you could play with.
Oh, cool.
So that's Pippi. Yeah.
Yeah. I wonder where the name Pippi comes from, because the only thing that I see that and I immediately think Pippi Longstocking.
Yep.
And like,
sure.
I have no idea if that actually is.
Is that with a Y or no?
Yeah.
Yeah.
It is with an I. Okay. I don't know. It could be. Yeah, the site is pippi.world, which is pretty cool. Yeah, and a lot of people collaborated with them to kind of help create the library. But yeah, it's definitely an area that I'm intrigued in to kind of learn a little more. All right. So is there anything else, Jim?
Well, I think the project I've been playing with recently is something called Code Spell, which does spell checking for inside your source code to find errors in your comments and in variable names, which I thought was kind of cool.
Nice.
Yeah, nice.
Yeah.
Again, all this stuff will be inside the show notes, but I really want to thank you for coming on the show, Jim. It's been really great to have you as a guest.
Thanks for having me. Been great to be here.
And it's always great to talk to you again, David.
Yep, you too.
I want to thank Jim Anderson and David Amos for coming on the show again. And I want to thank you for listening to the Real Python Podcast. Make sure you subscribe to the podcast in your favorite player. And if you like the show, leave us a 5-star rating and a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.